Okay, then we'll move it. Okay, so just to begin, so if I could introduce myself, Christine Kilpatrick's my name. I'm the CEO of Melbourne Health, Royal Melbourne Hospital, and I'd just like to introduce two very important people. Firstly, Dr. Mike Catton, who is head of the Victorian Infectious Diseases Reference Laboratory, which we call VIDRL, and Mike is also the Deputy Director of the Doherty Institute, which is a partnership between the University of Melbourne and Royal Melbourne Hospital. And I also have beside me Julian Druce, who is the head of the Virus Identification Laboratory, and he's been intimately involved in this very important piece of work. So I'll hand over to Mike and Julian.
Thank you very much, Christine. So look, could I add my welcome to all of you today here to the Doherty Institute. I'd just like to start by saying how pleased we are to have been able to grow this virus in a very short space of time directly from a patient sample, and that's an art. And I guess Julian is the artist, who you'll possibly hear about on the technical detail. But much more importantly, that we've moved immediately to share this with our international colleagues to provide a toolkit that complements the modern molecular techniques that are so useful in diagnosis and development of vaccines and medicines. So there are some things that are just much easier to do when you have the virus in your hands, and there are expert laboratories internationally that haven't had access to the virus, and so this step makes it possible for a lot of things to move forward that have been delayed, and we're just delighted to have been able to fill that gap in the space between 2 a.m. Saturday morning, when the first case was diagnosed in Australia, and Monday, when we believe we had the virus growing in culture. So Julian and I will be very happy to take questions from you on anything you'd like to know. Thanks a lot.
So what's been involved in growing a virus, and what is the process? If you can step us through that, please.
Yeah, so look, it's an old school technique. The current diagnostics are very rapid and fast using molecular methods, but the old school techniques, you have or rely on cell lines or cell sheets that grow in a single layer of cells on a flask, and you inoculate or place some patient material onto those cells, and you hope that the virus in the sample gets into the cells and infects the cells, and then will produce a pattern in the cells that demonstrates that the cells are dying, and that's what we see, and I think the image of that's been put up on the web, and so you can see that the cells actually die in the progression of infection, and so that's how we know the virus is happening. And we've used the same test on that material that we use in patients to assess the level of virus, so that we know that the burden of virus or the amount of virus present is going up, and so we can prove that the virus is growing.
Is it a difficult thing to do?
So look, some viruses are very fussy in terms of the cells that they require to gain entry into the cells. So all viruses need the appropriate receptor on the cells to gain entry. So it's a little bit like a lock and key, and the virus has the key and the cell has the lock, and if the right things are present, the virus can get inside.
We happened to hearing that it happened very quickly. Were you surprised at the rapid rate that it did occur?
Look, yes and no. We've grown a number of these family of viruses in the past, and you've probably heard of SARS and MERS coronavirus, and they both grow relatively quickly in cell culture. So in some ways it didn't. But the international interest is obviously fascinating, and the fact that other people have not yet grown it. But there's only been limited spread outside of China at the moment, so not too many people have had that ability, and we're uniquely placed here that we've got both a diagnostic lab that's doing that work, plus these old traditional methods in the one laboratory that can bring those two together.
Can you run through for us the possibilities that this now creates? What's the next step?
So, yeah.
I'll take that one. So, in addition to the molecular techniques that might be used in the development of vaccines and medicines, the virus can be used in the assessment of the effectiveness of vaccines particularly, and of medicines. It also gives us the opportunity to create a first-generation antibody test. And that's important both in the clinical management of patients who may be late in the illness and past the point where they're shedding the virus that we detect with molecular techniques. And it's also really important for us to look at things like asymptomatic infection with the virus, that possibility, or mild infection that hasn't come to the attention of health authorities, and those patients haven't been tested and identified as cases. So really an antibody test is the only way to answer some of those important epidemiological questions, which get you to questions of how many cases and how does the number of deaths relate to the number of cases that you're seeing on the ground. So a great many things are possible with the virus that complement and add to what you can do with the fast and powerful molecular techniques.
If we were to start with the antibody test then, which obviously precedes the vaccine. At the moment it's being said that you don't know you've got coronavirus until you're showing symptoms, so you're saying that the antibody test will be able to prove if you do or don't before you start showing symptoms.
I should clarify, those clinical diagnosis is done when you recognise that you have a patient and you really need a clinical illness to have that patient front medical care. What I was talking more about is what are called seroprevalence studies, where you look at a population and you look at the rate of antibody positivity in that population so that you can find out what the wider number of patients that are infected is. So I think the mainstay of clinical diagnostics and public health will remain the molecular techniques because they're so fast and they're so powerful. The antibody techniques are a complement and help us understand the epidemiology of the outbreak in that sense.
How much further along then does this take you towards getting the vaccine?
Well, that's really outside my direct area of expertise. I'm not someone that develops vaccines for a living. I'm a public health person that develops tests and is part of public health responses. But it's a key step in development of vaccines to assess vaccines. Animal models are very helpful. So there are colleagues that are working in Australia to develop models to test candidate vaccines on. Having the virus is a crucial step to allow them to proceed. They thought they were going to have to wait for some time to import the virus from somewhere else. Now we are in the process of getting the virus to them.
When you say them, are you referring to the WHO?
I'm referring to CSIRO. That's one of the groups. So that's also here in Victoria, and that's a very expert lab that have worked in the past on animal models.
There's also researchers and scientists in Queensland that are trying to work
Quite true, yeah.
the vaccine. So are you working hand in glove with them, or is it perhaps just with
I've actually seen an email in my email box that I haven't had time to read this morning because we've been so hard pressed. I have no doubt that conversation's about to take place, but I can't say that it has yet.
And then with that process, would it be that you would hand them over what you have formed here today, or is